Hello, friends. This review turned out to be quite large, as it covers 5 devices. These are Zigbee-controlled GU10 base bulbs. They all have roughly the same parameters, modes for colored and white light, size, and a stated power of 5 watts. However, they differ significantly in cost. In this video, I will compare their functionality in several control systems: Tuya Smart, Ewelink, Apple HomeKit, and Google Home. Additionally, I will check compatibility with Sun-Off iHost and Home Assistant through Zigbee and Zigbee 2 MQTT integrations. We'll test group mode operation and compare light levels. Before we start, as is tradition, I ask you to like this video. It helps promote it on YouTube, and subscribe to my channel if you haven't done so already. As I said, the test involves 5 bulbs from different stores. To avoid confusion, they were all marked with numbers, and you will find their links in the description using the same numbers. Let's meet the test participants. Next, I will list the parameters of each bulb, at least those that I could find out. In most cases, I had to use the store name from where the specific device came as identifiers. There are some parameters common to all concerning the base and declared power, so I will not mention them. For the first bulb, a luminous flux of 330 lumens and a color rendering index of at least 90 are declared. The range of color temperature in white mode is from 2700 to 6500 Kelvin. I did not find data on the angle of the light flux. The second bulb, the same size and very similar in appearance. I did not find data on the light flux and its angle. The color rendering index is at least 80. The color temperature range is from 3 to 6000 Kelvin. Number 3. This bulb has a specific model and manufacturer, GU10. The light flux ranges from 300 to 450 lumens, with a 30-degree angle for directional light. The color rendering index is at least 80. The color temperature range is from 2200 to 6500 Kelvin. The fourth bulb is the largest in the test. However, the difference is just a few millimeters. The light flux is 400 to 460 lumens, with a color rendering index of at least 80 and a 120-degree angle. The range is standard from 2700 to 6500 Kelvin. The fifth participant in the testing has the highest declared light flux of 500 lumens. The color rendering index is unknown, but likely at least 80, with a 120-degree light beam angle. It resembles the first and second bulbs in appearance, but is slightly more compact with a convex diffuser. When the bulbs came into my hands, I noticed one detail: they clearly differ in weight. Weight can indicate the quality of cooling, I mean the radiators, and the first comparison will start with his weighing. The first bulb falls into the medium weight category, almost 32 grams. The second is a bit heavier, just over 34 grams. The heaviest is the bulb from GU10, 57.5 grams. Close to it is the fourth test participant, weighing nearly 52 grams. And the lightest turned out to be the fifth bulb, just under 26 grams, half the weight of the third and fourth samples. For this review, I had to make a separate test stand that can accommodate all the bulbs at once. All 5 test participants, upon first connection, did not enter pairing mode. For this, which is relevant for all, you need to turn the power off and on 3 times with a 1-second interval. When the breathing mode is activated, it means the bulb is ready for pairing. If it doesn't work, try turning it off and on not 3, but 4 to 5 times. We'll start testing compatibility with control systems using Tuya Smart. For this, I use a wired gateway with Apple HomeKit support, which also allows me to test it. We turn on the mode for connecting child devices on it. Activate the pairing mode on the bulb. The gateway detects and connects it. All test devices connected without any problems. In the system, I named them according to their numbers to avoid any confusion. This photo clearly shows the placement and number of LEDs under the diffuser. In some, they are very conspicuous, while in the fourth and fifth bulbs, they are less noticeable. Regarding the plugins, the plugin for the bulb numbered 1 is different from the other 4, which I will show later. The main window, after the bulb is turned on, consists of 4 tabs. The first 2 are modes for white and colored light, where you can control brightness, color temperature, and color, respectively. Then there is a tab for preset scenes, which includes both static and dynamic light modes, and a music mode, in which the bulb changes lighting to the beat of the music. For this, the phone's microphone is used. At the bottom, to the left of the power button, is the timer menu. This sets a period after which the bulb will change its status to the opposite. To the right is the additional settings menu, which contains 4 items. The first is scheduling, which in turn offers 4 options. Random light activation within a specified time interval to simulate presence in the house. The cyclical mode also works within a set interval, but here you can specify how long the bulb will be on and off. For example, from 3 to 5 in the afternoon, light up for 1 minute, then off for 3 minutes. Wake up and sleep modes, when the light either gradually dims or, conversely, gradually increases in brightness. The time and duration are set. The scheduler allows you to turn on and off the lighting depending on the days of the week and the specified time, either once or periodically. The rhythms mode is something like adaptive lighting, whose brightness and color temperature depend on the time of day. Also in this menu, you can enable the Do Not Disturb option. In this case, if the bulb was off at the time of power loss, it will not turn on when power is restored. There is an option to set a default light mode. In the general settings, you can check the firmware version. Here it's 1.3.0, compatibility with third-party systems, Alexa, Google Assistant, and SmartThing are claimed, as well as create a group, give shared access, and remove the device from the system. The plugin for the other devices looks like this. By the way, the screenshots are specifically made on different bulbs. The main window has only 3 tabs, white, colored, and music mode. There are no scene tabs. Also missing are the 2 menus at the bottom, timers, and settings for the scheduler, rhythms, and state memory. So these 3 tabs are essentially all the available features. In the general settings menu, only 2 systems are listed. SmartThing is absent, and the firmware version for all the remaining bulbs is 1.0. All 5 bulbs can be grouped together. Interestingly, in the group list, even the icon of the first bulb differs from the others. Everything added to the group can be controlled as one common object. The plugin looks the same as for most of the bulbs. However, I assume that if it were necessary to combine several bulbs of the first type, then the group plugin would have all the corresponding settings. Group operation. The control is synchronous, and the response is quite fast. Certainly, for practical use, identical bulbs should be used to ensure the light has the same shade and power. With different bulbs, as can be particularly noticed in the colored mode, the colors may differ. Music mode operation in the group. Each bulb lights up in its own way. I think that when using identical devices, they would work synchronously. Now let's move on to automations. Let's start with the triggers section, monitoring changes in device status, after which automation is triggered. All 5 bulbs can be triggers. The first bulb has the most options. It turned out to be the most functional in the Tuya Smart system. You can track changes in status and mode. There's also the option to track changes in brightness and color temperature, in both cases in percentages, although for temperature, degrees Kelvin would be more logical. You can monitor the timer status, whether it's more, less, or equal to the set interval, the status of the Do Not Disturb mode, and even the signal level limit, though I'm not sure why this option is occasionally present. For the other test participants, in the Triggers section, only 3 options are available. On-off switching, and more/less/ equal to the set value of brightness and color temperature. Here, it's not percentages but some arbitrary units on a scale from 0 to 1,000. The Actions section, what the automation will do if its trigger is activated. Here, too, not only all 5 bulbs were found, which is logical, but also our created group. The first bulb is the most functional, with all the same 7 options we saw in the trigger. Only here, they are not monitored, but set. In the on-off section, there is a notable absence of a toggle state option. Brightness and color temperature are also set in percentages. And if it makes sense for brightness, for temperature, you'll have to guess and adjust. You can also set a timer. Upon its expiry, the bulb will switch its state, the Do Not Disturb mode, and the signal level limit. For the other bulbs, there are only 3 items, but they are much more convenient, starting from the ability to not only turn on off the bulb but also toggle its state, and ending with intuitive sliders for setting the lighting mode, not just white but also colored, which was not available in the first case. These same 3 options, in exactly this implementation, are also available for the group, which can also participate in automation, and this is more convenient than duplicating the same settings for each bulb separately. Now, let's check the declared compatibility of all the bulbs in the test with Google Home. For this, remember, you need to enter your Tuya Smart account credentials once. As you can see, all 5 bulbs, under the same names, are also available here. On-off is accessible from the main screen, and to set parameters, you need to enter the device card. The control is the same for all test participants. You can set the desired brightness, color temperature in white mode, and hue in color mode. Compatibility confirmed. As I mentioned earlier, for the test in Tuya Smart, I use a wired gateway with Apple HomeKit support. And to check this compatibility, I am using the Home Assistant integration called HomeKit Controller. Everything that will be available in it will also be available in Apple HomeKit. Besides, this is one of the options for integration into Home Assistant itself. Out of the 5 added to the gateway, only one appeared in HomeKit under a standard name. It's easy to check. Just turn it on and off. Although, I think everyone has already guessed which bulb it turned out to be. Of course, it's number 1, with the most functional plugin. Available are on-off, changes in brightness, color temperature, and color. Unlike the native Tuya integration, which we will also check now, this one does not depend on internet access and works locally. Compatibility with HomeKit, with the appropriate gateway, is confirmed only for the first bulb. By the way, it was not declared for any of the test participants, so this can be considered a bonus. In conclusion of the section dedicated to Tuya Smart, let's check the eponymous integration in Home Assistant. Similar to Google Home, it works through a cloud account. All supported devices appear here automatically. All 5 test participants were no exception. The control across all devices is the same, so next, I'll show screenshots of different tabs from different devices. The standard set includes on-off, brightness control, color temperature in white mode, and shades in color mode. Remember, this integration depends on having internet access. Another point, everything shown in this section, the Tuya app, control in Google Home, HomeKit, and this integration, works simultaneously. Before moving on to the next section, I'll share another observation. After a bulb is removed from the system, this option is found in the General Settings menu. It automatically goes into pairing mode. And if you want to not just remove it but transfer it to another system, to another gateway or coordinator, then you need to put it in the mode for adding new devices beforehand. Then the bulb, this is relevant for all test participants, will automatically switch there immediately after removal. That's exactly what I did to check compatibility with the Ewelink smart home management system. As a Zigbee gateway, I am using the Sun-Off NSPanel Pro. The review link is in the description. Thanks to the automatic switching of the bulbs into pairing mode, transferring all 5 took just a couple of minutes. The Sun-Off gateway was in search mode, while I was removing the bulbs from Tuya Smart, and they immediately appeared in Ewelink. All were successfully added. The plugin for the first bulb in this system is different from all the others, but now towards lesser functionality. Besides on-off, only brightness is available and that's it. No color temperature or change in glow shade. The additional options are only a timer and scheduler. The operating principle is similar to what we reviewed in Tuya Smart. In the General Settings menu, apart from the list of compatible third-party systems, here compared to Tuya, many Chinese systems were added. Nothing interesting was found. For all other bulbs, control of all modes is available. Screenshots are specifically made from plugins of different devices. There are both brightness and color temperature, from warm to cool white and color mode. The additional options are the same as for the first test participant, timer and scheduler, which allows setting automatic on and off at specified times and days of the week. The General Settings menu is minimalist, with a list of supported systems, location, group creation, and deletion. You can group together only devices with similar functionality, meaning bulbs from the 2nd to the 5th, which have full control over all lighting modes. This will be useful for synchronizing their operation, for example, when they are installed in one chandelier or are in the same lighting zone. Unlike a regular gateway, NSPanel Pro has the advantage of allowing control of all connected devices from its screen. This is what it looks like in real time. On-off is available from the main screen, and to control all modes, you need to enter the device card. Everything is quite fast and convenient. Also, as a reminder, shortcuts for manually triggered automations can be displayed on the screen, for instance, to turn on several devices with set parameters. Let's look at the capabilities and automations and start with the if section, the triggers. Changes in the state of smart devices can also be such triggers, and all 5 bulbs are available for use here. The possibilities are the same for all models. As automation triggers, you can only use changes in statuses turned on or off. Now regarding the actions of automations. Here, there are differences in functionality. For the first bulb, as in the plugin, only brightness setting is available, besides on-off, of course. But for the others, the full set is available, besides the already listed changes in color temperature, as well as color and its saturation. Like Tuya Smart, the Ewelink account can also be added to Google Home. In this case, all 5 test participants were also included in the system. But for the first bulb, apart from on and off, only brightness control is available. Although when working with the Tuya gateway, all modes were accessible. In the case of Ewelink, you can control the brightness and color temperature only for devices numbered 2, 3, 4, and 5. But overall, all devices are compatible with this control system, with the caveat of limited functionality for the first bulb. Shortly before this testing, 2 reviews about the Sun-Off iHost Smart Home Control Center were released on my channel. By the time you watch this video, there might be more. Now, we will check the compatibility of all the bulbs with this interesting device, which includes among other things a Zigbee interface. The current firmware as of the test date is 1.13.0. Currently, several Zigbee devices and a camera are connected here, about which I talked in the first part of the video about iHost. In the offline status is the USB Wi-Fi Relay Sun-Off Mini, which I discussed in more detail in the second part of the video. You will find links in the description. As I said, this device has its own Zigbee coordinator on board and, at least as of the testing date, supports up to 128 connected devices simultaneously. We initiate the connection mode and start activating pairing on the child devices, in this case, the bulbs. I used the same method I already mentioned. I simply started removing the bulbs from Ewelink. After which, they automatically enter pairing mode and immediately come under the iHost coordinator's detection. I only had to name them, following the same principle: number, store name, or model. All 5 test devices connected. It's noticeable that the first bulb here is also different from the others. And indeed, for it, just like we saw on the Sun-Off NSPanel Pro, besides on-off, only brightness control is available. This was somewhat expected. In the device settings, apart from changing the name and location, you can see in which automations it participates, the signal quality level, and the manufacturer's code. There's a setting for behavior after power restoration, always on, always off, and remember the last status. For all the other bulbs, all lighting modes are available. On the first tab, white light with adjustable color temperature. On the second, color. Of course, brightness and state control are included. I will not repeat these screenshots. They are the same for models 2 to 5. The General Settings tab, particularly in terms of setting up post-power restoration behavior, is the same for versions 1, 3, 4, and 5. This feature is absent in bulb number 2. Here are the settings of the other bulbs. They differ only in the manufacturer's name. There is also the possibility of creating groups. This is a very useful function, especially for controlling multiple light fixtures. You specify the group name, which is a mandatory field. Location is optional. Then you add all the desired devices. Here I selected all 5 bulbs. And, as expected, in this group of light fixtures, only on-off and brightness change are available. That is, the functionality is built on the simplest device. So, I tried again, but this time I added only 4 bulbs to the group, excluding the first one. In this group, along with on-off and brightness, the ability to change the color temperature was added, and a color selection palette. Changes occur synchronously on all the bulbs added to it. In Sun-Off iHost, there is also the functionality to create automations. To monitor changes in device status, you need to select the Smart Devices item, and then in the next menu, the desired device. After that, another list appears, in which you will see events available for usage triggers. In this case, only the status turn on/off. The same for the other bulbs. Everything completely matches what we have already seen in Ewelink. Similarly, we select the device for the Actions section. At the time of the test, groups here are not available. For the first bulb, you can choose on, off, and toggle the state, and of course, when turning on, you can specify the required brightness level. For the other bulbs, besides the listed options, there is the possibility to set either the color temperature for white mode, or select the desired color of light from the palette. And now for the third time, we turn to Google Home. While I was conducting the previous tests, my smartphone switched to evening mode, hence these screenshots. Unlike Tuya Smart and Ewelink, where devices work through cloud accounts, Sun-Off iHost is connected locally as a matter bridge. Otherwise, the functionality is similar to Ewelink. For the first bulb, besides on-off, only brightness is available. For the others, additionally, control of color temperature and color. The main difference, as I mentioned, is that iHost is connected locally and Google Nest is used as the control center. Now it's time to move on to Home Assistant, starting, as usual, with the native Zigbee integration for working with Zigbee devices. Here I am using the Sun-Off Zigbee dongle USB stick with multipan, RCP, firmware for Zigbee and thread support. More details in my video, link in the description. They work by the already tested scheme. Here I initiate the search and connection mode for new devices. And on the iHost, I remove the bulbs from the system. And, as they are removed, they start appearing in Zigbee. Simple, fast, and convenient. Here are all 5 test participants connected normally. Note that the second and fourth numbers are identified exactly the same, even though they don't look alike. Let's move on to the control capabilities. The first device consists of 5 objects, not counting 2 hidden ones. The first is a light fixture, which is comprehensive, offering control of all other parameters besides on-off. If you enter its menu, there are 3 tabs available. The first is for brightness control, though at the bottom, there is a panel with icons setting a specific color temperature or color. And there are separate tabs for flexible adjustment of the temperature from warm to cold white, or to select the desired color from the palette. Behavior after power restoration has 4 options: always on, always off, toggle the opposite state, and store the last status. There are also 2 options, the first for setting the color temperature at power on. The second is for setting brightness, but I did not see any visible impact when changing these parameters. However, the state memory works correctly. The second bulb. Here there are only 2 objects, the light fixture and the identification button. And in the light fixture card, there are 2 tabs, brightness and color palette. At the same time, the change in color temperature works normally when choosing one of the quick modes at the bottom or through automations. The third light fixture, GU10. Here everything is similar to the first, including the modes of behavior after power restoration. And 3 tabs, brightness, color, and white mode when launching the light fixture card. The fourth light fixture, which, as we remember, was identified exactly like the second but has functionality like the first and third, 5 objects, including state memory, and all 3 tabs on the light fixture control card. But the fifth turned out to be the same as the second. Only the light fixture and the identification button, and 2 tabs on the light fixture card, although the change in color temperature also works with circles and automations. Let's move on to Zigbee 2 MQTT. At the date of the test, the current version was 1.35.1. The coordinator was set up using the CC2652P2 module. The connection technology is well established. I activate the mode for connecting new devices, and I remove all the bulbs from Zigbee in turn. I wait until they all complete the interview and connect. Then I identify which is which and rename them accordingly. The second and fourth were identified the same. Here they all are on the control panel. Everything was recognized, control works, no external converters needed. Let's look at the capabilities of each device. The first bulb's converter, judging by the description, is identical for both GU10 and E14 versions. In the Zigbee network, it acts as a router. On the exposures page, 5 items. On-off, brightness control, color temperature control, not only with a slider but also with 5 preset positions, and a color palette. The fifth item is the signal quality level. The second bulb was identified as a Lamp bulb with an E27 socket. Incidentally, I have exactly that in its original form. Also a router, like all the other test participants. The control panel is the same as the first bulbs, standard for Tuya light fixtures. The third bulb is from GU10, the only one with a clearly defined model number, for which there is its own separate converter, including a correct image. On the exposures page, there are a few additional fields, color temperature to be set at startup, 2 color palettes, but they work the same. There is a menu with effects, though they work somewhat strangely, mainly just causing the bulb to blink, after which it takes a while to respond to commands. Then it passes. The fourth bulb, which was identified the same as the second, as an E27 version from the lamp store. The exposures page is standard, with 5 items. And the fifth bulb also identified as one of the E27 versions for Tuya Smart. And its exposures page is the most interesting, as besides the items we've already seen, there is a Do Not Disturb mode. Remember, if activated, a bulb turned off at the moment of power loss will not turn on upon its restoration. There's also a setting for the type of lighting upon power application. In Zigbee 2 MQTT, there is a possibility to create groups, and for groups, there are special devices that can control everything added to it. One such device is the wireless MOS dimmer. You can find a link to its review in the description. In the group menu, I create a new one, with a name of my choice, and it's advisable to use a 3-digit identifier and not in the first 100 to avoid accidentally catching control from some device. I add all 5 bulbs to it. Since they act as routers, they appear in the group by themselves. And the dimmer is an end device, so after you add it to the group, you need to wake it up by pressing its button, then it will appear in the group. The control works as follows. Pressing the dimmer button turns the entire group on or off. Rotating controls the brightness. Rotating while pressing the button changes the color temperature, and holding the button changes the color. A few notes. First, the good. Such control is completely autonomous and will work even with a non-working Zigbee 2 MQTT and turned-off coordinator. Now the specifics. When controlling, the modes are not synchronized but simply receive commands for change. For example, if the bulbs were operating in different modes, they will turn on that way, and you'll need to adjust the brightness and color temperature to the maximum and minimum to align all values. In color mode, when holding the button, the bulbs change colors differently. You can try to align the modes using separate automations. The second test with a Zigbee remote, you can also find a link to the review in the description. It operates on the same principle, adding to groups. Moreover, it can work simultaneously in 8 groups, for which it has corresponding buttons. Details are in the review. Their identifiers are strictly defined, 108, designated for the remote's large pair of buttons, the most convenient ones. In the group, we add only the bulbs. The remote doesn't need to be added. Its buttons are fixed to groups at the firmware level. This is its peculiarity. In one Zigbee network, you can have only one remote, as others will have the same groups. But you can connect as many dimmers as you want. However, when controlling, you send the exact lighting mode, and all bulbs synchronously transition to it. Brightness, color temperature, and color are changed with touch panels. You can set the desired mode with a single press. And the last test for today is a comparison of the light flux intensity. The test will be conducted in neutral light mode at maximum brightness. The same for all bulbs. To ensure equal conditions, I will connect all bulbs to the same socket, under which the lux meter sensor is located. I should clarify that these values can only be used for comparing the bulbs with each other. The first bulb, 1230 lux, here a tenfold coefficient is applied. The second, 900 lux, the lowest value, but the color on these settings is noticeably warmer. However, I decided not to set a colder one, for the purity of the experiment. The third, 1100 lux, but here too, on these settings, the color is warmer than the first bulb. The fourth, the shade on these settings turned out to be slightly colder, and the value is 1380 lux, the highest in this test. And the fifth bulb, 1010 lux, with the shade here being clearly colder, and the colder it is, the higher the value. As you can see, despite very similar parameters, the bulbs have differences both functionally and in their physical parameters. Which one to choose depends on where you plan to use it. For example, in Tuya Smart, the first model is the most functional, and it is the only one that is supported from the Tuya gateway and HomeKit. For Zigbee 2 MQT, the most functional turned out to be the fifth bulb, which has a Do Not Disturb mode. Regarding quality, I personally preferred the third and fourth. The second didn't stand out in any particular way. Although the review turned out to be quite extensive, I might have missed some points, and it would also be interesting to know how you like this format in the form of comparison. Write your opinion in the comments. That's all. I hope the video was useful and interesting to you. I would be grateful for your likes. They help with promotion on YouTube. If you don't want to miss reviews and lessons, subscribe to my channel. In the video description, you will find all the necessary links to the devices that were included in the test, to the mentioned reviews, as well as my Telegram channel, Facebook page, and group for communication on smart home topics. Join us. It will be interesting. Thank you for your attention. Until new meetings. Peace to everyone.